Let's talk about triangulation. So, triangulation, in many situations, certain geographical or topographical features like hills and valleys are not accessible to a survey. So you can imagine, people walking around the countryside, but they can't get places because hills and valleys are in the way. To find important locations or features, triangulation is used. This technique requires coordination of bearings from two known locations, for example fire spotting towers, to a third inaccessible location, the fire. So here's a little diagram. So we've got the two towers here, and between them, they can say, okay, tower A, we've got that bearing, we've got a bearing to where they can see the fire. Tower B has got a bearing where that fire is, and with all that information we can figure out exactly where that fire is. Triangulation should be used when the distance between two locations is given and the direction from each of these two locations to a third inaccessible location is known. Okay, for triangulation, we often use the sign rule to find distances from the known location to the third one, to the inaccessible one. And we also use the cosine rule sometimes if we've got to find another place. So let's have a look at some examples. We've got two fire spotting towers that are 7 kilometers apart. So A and B, 7 kilometers apart on an east-west line. That means they are directly B is due west of A. From Tower A, a fire is seen on a bearing of 310 degrees true. Okay, you can see, all right, from A, got that 310 degrees to where they see it. From Tower B, the same fire is spotted on a bearing of north 20 degrees east. Now, let's look at this for a second. That will translate to 20 degrees true. Okay? Which tower is closest to the fire, and how far is that tower from the fire to one decimal place? So our first step is to draw a sketch of the situation, which we've got here. Now we use triangulation because we know how far apart the two fire towers are, fire spotting towers, and then we can see, okay, what bearing that fire is, but we can't tell how far away it is. So we need to be able to figure that out so we can tell the firefighters where that fire is so they can get there. So we've drawn the sketch. We need to identify the known values of the triangle and label appropriately for the sign rule. So you can see we've taken this triangle here and put it here. Now because that's 20 degrees in there, that has to be 70 degrees, which they've put there. Okay? Because of course they add up to 90 degrees. Now it's 270 degrees around to there, to that line, to the east-west line. So in there, 310 degrees take away 270 is 40 degrees. So that's how they've come up with that there. Now 70 plus 40 gives you 110 degrees. 180 take away 110, 70 degrees. Okay. Now this also tells us that's an isosceles triangle, doesn't it? So because those two angles are equal, that means those two sides must also be the same length. Okay, the shortest side of a triangle is opposite the smallest angle. It's a nice little bit to know. Therefore, tower B is closest to the fire. Use the sine rule to find the distance of tower B from the fire. Okay, so backside C, backside A. So we've set that up here. Okay, there it is. So we substitute into the formula, and there we go. So working it out, we get tower B being 4.8 kilometres. And yes, because that triangle is isosceles, tower A is 7 kilometres. And it's isosceles because those two angles are the same, therefore that side and that side are the same. They are both 7 kilometres. So sometimes we can use similar triangles to solve triangulation problems. In order to do so, we need two corresponding lengths to establish the scale factor between the two similar triangles. So we need to figure out that scale factor, the K factor, okay, and the corresponding lengths. A second accessible side we use to scale up or down to the corresponding inaccessible side. Now this here is the proof for similar triangles. In other words, how do we know something's a similar triangle? If all three angles, if the corresponding angles are the same, if all corresponding sides are in the same ratio, if the side angle and side are in the same ratio, and this means with the included angle, the same included angle. The sides are in the same ratio and the included angle is exactly the same. So example of that is here. Find the unknown length x from the pylon to the edge of the lake. So you see here, okay, we've got a pylon in the middle of a lake, which is just like a pole. We don't know how far it is from there to the edge of the lake. What we do know is that distance from that point to point A, it's 39 metres in total. And we know the distance between point A and point B, which is 20 metres. So we then, to make life easier for ourselves, we draw the triangles separately, highlighting the corresponding sides. So we can see, okay, there's that small triangle there, 3 and 20. Then we've got the larger triangle there, which we've got 36 and x. So now it's down to the two triangles. I then want to figure out my scale factor. So in similar triangles, or corresponding sides are in the same ratio. So you can see comparing 3 to 36, same as comparing 20 to x. So figuring then out for x is 240 metres.